Hi, I'm Sven. One more thing about model abstraction. We all know that it's virtually impossible to find a model for our decision making that takes into account every level of detail. Douglas Adams has shown us what may happen if we try. But then there are these so-called digital twins out there. How does this work if modeling is so complex? So today, let's have a look at data abstraction. Welcome to Obtaino. If we want to learn something about a complex situation, we create a model and run a simulation. A model in this sense is a representation of that part of the world we are currently interested in. A simulation uses this model and plays around with it. Let's see how it behaves if we do this or poke here. The idea behind this is that the model behaves as realistically as possible compared to its inspiration in real life. And this is why it's often called a digital twin. There is a pitfall to this, and a huge one. To behave as realistically as possible, we need to add as many details as possible. Let's use our pizza example. We want to model different varieties of pizza. We just use two toppings, either meat or veggies. This is one level of granularity, resulting in only two options. Simple, but very abstract and probably not sufficient. So we replace the basic model with a more refined one that replaces every option with two new ones. Two types of veggies, two types of meat, resulting in four options. Still, for me, that's not sufficient. So we repeat and replace each of these options with two more refined ones, ending up with 8 options overall. We doubled it. Again. And we did not even allow for combining our toppings. Adding more levels of detail to a model means its size grows exponentially with the level of detail we need. And as of today, every child knows that exponential growth is a very bad idea. But we need to find models for decision making anyway, right? And this is where the experts meet, in terms of modeling and in terms of the problem domain, being it pizza or supply chain planning. We want to explore the details of a model, but we must avoid the exponential growth at all costs. The solution is modesty. We remove all the details that do not contribute sufficiently to our decision. It might be that they contribute something, but not enough to be relevant. In terms of pizza, if we are not into meat, we remove this branch of the model entirely and only concentrate on the details we are looking for. The challenge? The model is still structurally exponential, and this is the art and the joy of modeling experts. Find the balance of details and abstractions that can still model our problem, but keeps it manageable at the same time. The need for abstraction when modeling a problem sounds like a hollow buzzword, but it's at the core of successful optimization. It's also the secret sauce of digital twins that are very detailed in a very narrow area, but that omit everything else in a radical way. So it's worth it to think at least twice when modeling some interesting but irrelevant aspect of our problem to avoid exponential growth wherever we can. See you next time and stay safe!